Hi friends, today's talk will be based on the IUPAC nomenclature of an organic compound. I will provide some tips and tricks for the IUPAC nomenclature in organic chemistry. It will take only 5 minutes to learn the IUPAC nomenclature, the rules and the tricks and the tips for the organic compound. So let's dive in this tips and tricks methodology for IUPAC nomenclature. So this is one of the representative example. Its IUPAC nomenclature is Z2-chloropentane in 1-ol. So why IUPAC nomenclature is important? The first one is provide the systematic naming of an organic compound. The full form of IUPAC is International Union of Pure and Applied Chemistry, and it provides the standardized system for an organic chemist to communicate about the chemical structure. So IUPAC is the Union of an Pure and Applied Chemistry. They give a name to an organic compound which is used in the whole world. The name of this compound will be according to IUPAC will be same in the all countries. So why IUPAC nomenclature is important? Let us see. So it provide the clarity. The IUPAC name are assigned to be unambiguous, providing a unique name for an every distinct compound. Universality. IUPAC nomenclature is internationally recognized, facilitating communicating about the chemist worldwide. And systematicity. The system is based on a set of logical rules. All chemists to deduce the structure of a compound from its IUPAC name and vice versa. So it has a specific rule which has been accepted by the chemists all around the world. So I will provide tips and tricks for using this rule in IUPAC nomenclature. So this is our early example. As I have told, the IUPAC name is Z2-chloropentane 1-ol. So the simplest tips and the tricks to remember the IUPAC name of an organic compound. It has an 5 parts. So divide this IUPAC name in a 5 part. The first part is Z, second is the 2-chloro, the third is the pent, the fourth is the 2-in, and last one is the all. So I have divided this nomenclature into 5 parts. The first part represents the stereoisomerism, second part represents the substituent, the third part represents the parent chain, the fourth part represents the sites of unsaturation, and the last part represents the functional group. So the first tip is to derive an IUPAC name of an any chemical compound will depend upon these 5 parts in chemical compound. So let us see these 5 parts in detail. So this is the common example I have chosen. So the first one is the stereoisomerism. This Z represent the geometrical isomerism such as cis and trans, and for chiral isomerism it will represent the R and S. The second part is the substituent. The substituent can be hydrocarbons such as methyl, halides such as chloro, bromo, or another functional group such as amine or any other functional group. The third one is the parent chain. Parent chain can be methane, ethane, propane, butane, pentane, hexane, heptane. It can be up to the carbon number 10. And unsaturation can be double bond or triple bond. And the functional group can be carboxylic acid, aldehyde, alcohol, amines, ketone, ester, etc. So to 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 have an IUPAC nomenclature, IUPAC name of any organic compound is based upon the 5 parts that should be remembered. The first one is the stereoisomerism, the second one is substituent, the third one is the parent chain, the fourth one is the sites of unsaturation, and the last one is the functional group. So by applying the IUPAC nomenclature of a given example, it can be clearly seen that the Z is the isomerism, that is Z represents the cis isomerism, 2-chloro is the substituent at the second position with respect to functional group alcohol. The pent represents the pentane chain 1, 2, 3, 4, and 5. So it is a pentane chain. The fourth one is the 2-in. 2-in represent the double bond at the second position, and the 1-all represent the hydroxy group at the first position. So this is a simple trick. Divide a given organic compound in 5 parts. The first part should be stereoisomerism or geometrical isomerism. The second should be the substituent. The third should be the parent chain, and the fourth should be the sites of unsaturation. And the last one is the functional group. Hope you like my video. Please share and subscribe.